Welcome to another Induction Logic quick video. We have modeled the POWERNATION race engine build. It is a 440 cubic inch Motown small block Chevy with LME LS 7-cylinder heads and a custom designed camshaft from Comp Cams. All of their engine values are entered and their custom Comp Cam is about 50 horsepower short. It is 254 duration at 50 on the intake and 268 on the exhaust, with 765 thousandths gross lift on the intake and 783 thousandths on the exhaust. It was ground on a 110 intake and 118 exhaust lobe centerline. Comp's intake profile is 5 degrees shorter at 50, with 60 thousandths more valve lift, and their exhaust profile is 2 degrees shorter at 50, with 85 thousandths more valve lift than our displayed cam values. And that is after adding the valve lash to our net valve lift values. The peak piston CFM demand is 363 CFM at 644 thousandths intake valve lift, which is the intake valve lift of the displayed camshaft at maximum piston velocity. The intake port flows 383 CFM at 600 thousandths valve lift, so our 694 thousandths net intake valve lift is more than enough. Increasing the lift doesn't always make more power. In fact, too much valve lift can kill the horsepower and peak torque numbers. In this case, the cam was too short and the additional area from the additional lift let the engine peak horsepower at 7,700 RPM. Though not efficiently. This engine should have easily made over 850 horsepower, but was well short at 721 corrected brake horsepower. An LSX 454 factory crate engine makes 630 horsepower at 6,300 RPM with 11:1 compression. Though the cam is not correct for this short block and head combination, there is something else bad wrong. Here is the engine's torque curve compared to a healthy torque curve. To prove my point, I'll change the compression from 13.9 to 11. Now, using the camshaft displayed on the screen, this engine should make 743 horsepower, or 22 more than they made with 13.9 compression. Thanks for watching.